In this discussion on electrical measurement, we will talk about Owen's bridge. The topics of discussion are definition of Owen's bridge, schematic of the bridge, balance condition of the Owen's bridge, phasor diagram, and advantages and disadvantages of the Owen's bridge. The Owen's bridge measures the inductance in terms of capacitance. It is also a modification of the Wheatstone bridge and it is an AC bridge. It works on the simple principle of comparison, that is, the unknown value of the inductor is compared with a known standard capacitor. The schematic model of the Owen's bridge is shown here. AB, BC, CD and AD form the four arms of the bridge. The arm AB has the unknown inductor L1 with a resistive load R1. The arm AB is purely inductive. The arm DC is purely resistive with resistance R3. Similarly, the arm CD has fixed capacitance value of C4. The arm AD has the variable resistor R2 and a variable capacitor C2. The AC voltage is connected between the terminals A and C. The unknown inductor L1 on arm AB is compared with the known capacitor C4 connected to the arm CD. The bridge balance is maintained by adjusting the variable resistor R2 and variable capacitor C2. At the balanced condition, no current flows through the detector. The end points, that is B and D of the detector, are the same potential. At balanced condition, we get R1 plus J omega L1 into 1 by J omega C4 equal to R2 plus 1 by J omega C2 into R3. Equating for the real and the imaginary parts, we get L1 equal to R2 R3 C4 and R1 equal to R3 into C4 by C2. Here we see the phasor diagram of the Owen's bridge. The components I1, E3 and E4 are in phase. These components are placed in the horizontal axis where E3 is given as I3 R3 and E4 is given as I2 by omega C4. The voltage drop I1 R1 is also in the horizontal axis. The current I2 and the voltage I2 R2 are in the vertical axis. The supply voltage is the summation of E1 and E3. The sum of the inductive voltage drop, that is omega L1 I1, and the resistive voltage drop I1 R1 gives the voltage drop E1 in the arm AB. When the bridge is in balanced condition, the potential E1 and E2 across the arms AB and AD are equal. Thus, it is shown on the same axis. The voltage drop E2 is the summation of the resistive voltage drop I2 R2 and the capacitive voltage drop I2 by omega C2. The I2 of the AD arm leads by 90 degree with the voltage drop E4 of the CD arm because of the fixed capacitor C4. The advantages of the Owen's bridge are as follows. The balance equation is easily obtained. The balance equation is simple and does not contain any frequency component. The bridge is used for the measurement of the large range inductance. The disadvantages of the Owen's bridge are the bridge uses an expensive capacitor which increases the cost of the bridge, and also it gives not so good accuracy. The value of the fixed capacitor C2 is much larger than the quality factor Q2. For further detailed reading, the viewer can refer to the following links. Thank you.